Okay, we're continuing with this pre-quiz warm-up. Number 4 says, write the following in sigma notation. So first of all, it's a series. It's finite too. You notice it ends at 42, so you can actually just count up the terms. 1, 2, 3, 4, 5, 6, 7. There's my n. Pretty easy. And then really not hard to see the pattern here. I just keep adding 5 every time. Add 5, add 5, add 5. That's my common difference. So clearly it's arithmetic. And I got, what else do I need? Common difference. I got n. First term is 12. That's a no-brainer. And I want to write this in sigma notation. So the first of all is you need the rule for the nth term. So you got to think of this as a sequence. And for an arithmetic sequence, any given term, the explicit formula says a sub n is the first term plus the common difference times n minus 1. So of course we start with 12. The common difference is 5 times n minus 1. Again, don't plug in n. We want the actual formula here, right? So if I simplify this, it's linear. It's 12 plus 5n minus 5, or to make it look nice, collector terms, 12 take away 5 is 7. So that's your explicit rule. So again, they said, write this thing in sigma notation. So draw yourself a nice capital sigma. If n is 7, make your life easy. Just make your index go from 1 to 7. So you have 7 terms. And in there, you're going to write your rule, which is 5n plus 7. I'm going to put a box around it. Yeah, this is easy stuff. Again, I would not fool with that index, you know. Just go, if it's 7 terms, just go from 1 to 7. All right. Our next topic was combinatorics. I really just dealt with combinations. We didn't do anything with permutation. So 5 is a pretty simple problem. 12 candidates are running for 4 positions on the school board. How many different outcomes are possible? So they're really saying how many different combinations, I'm gonna write combos, right? And the rule for this is out of 12 we're choosing 4. So that's 12 choose 4. And the rule is top number factorial divided by bottom number factorial times the difference. 12 minus 4 is 8 factorial. When you're doing these by hand, I always highlight the top number and the bigger number on the bottom. 12 factorial over 8 factorial is just 12 times 11 times 10 times 9. I stop there because 8 all the way down to 1 cancels with the bottom, right? So, you know, that part in lime green is the same. And then, of course, I still have 4 factorial, which is 4 times 3 times 2 times 1. And again, you really, for most of these, you don't need a calculator because you got some serious canceling, right? 4 times 3 is 12, so they knock out. You could take 2 and a 10 5 times. And then really you just have 11, you have 11 times 5 times 9, that's 55. 55 times 9, which is 495. 495. Right, so there's 495 outcomes in that election. All right, a couple more problems and we'll call it a day here. The third term of that expansion. So now we're talking about the binomial theorem. We start with a binomial coefficient, which is one of these choose numbers. If the top number is 7, I'm sorry, if the power is 7, that'll be the top number in the combo. If you want the third term, it's actually 7 choose 2. It's off by 1 because really the way it would work in that expansion would be 7 choose 0, 7 choose 1, 7 choose 2. So the third term is 7 choose 2. And then A and B are the 2 terms. To get the coefficient of B, it's always what's on the bottom here. This guy always goes up there. If you subtract 7 and 2, you get 5, it goes there. That's just the pattern. That's the easiest way to remember the binomial theorem. 7 choose 2. This time I'm going to do it on a calculator just to show you a different way rather than using all the factorials. On the 84, I guess the TI-84, you'd type in 7. You'd find the button for NCR and you'd type in 2. By the way, this is under the math menu, num 3, you'll find it. So that's on the TI-84. On Desmos, okay, you got to go to the function menu. It's under the function stat menu. Again, there is a button, NCR. You would hit that. And this time, it takes on a parameter. It takes on parentheses, and you type in 7,2. And again, just to let you know, this is under, you got to go to the function menu, and you got to go under stat, function stat. So there's a couple places on a computer you can get this. Either way, 7 choose 2 is just 21. Really not that tough of math. And then we have a to the 5th b squared, put a box around it because you're happier than a cat with 2 tails. Okay. All right, last problem here. I'm going to find the 4th term in this expansion, similar to what we just did, except a little tougher with the coefficients. So it's the 6th power. So it's 6 choose something. The 4th term, if you just subtract 1, it'd be 6 choose 3. I have 2x to a power, and I have 3 to a power. How do you get the powers? Bottom number goes with 3, right? And if I subtract 6 minus 3, I get 3. So really, I couldn't have screwed this one up. They're both the same power. 6 choose 3 is 20. Hey, should we show you one more way to get it? That's on Pascal's triangle. Yeah, it's such a small number. I'm going to recreate the triangle right here just to show you something different. You can see I'm just adding up the cells above. Right, and I want 6 choose 3. That's 6 choose 0, 6 choose 1, 6 choose 2. There's 6 choose 3 right there, 20. Again, you could have gotten that with a calculator. You could have done that with a formula. But there, I showed you Pascal's triangle. It's 20. 2 cubed is 8. 3 cubed is 27. 20 times 8 times 27 is 4320, and I still have an x cubed. Okay. Hey, guys, good luck on today's quiz.